This is the last video in our network series, Algorithm 5. We're doing maximum flow. I want you to have this diagram in your mind when I go into the next page and sort of explain some of the steps. Here's some of the terminology to be familiar with: source and sink. So the source is where we start and the sink is where we end. Imagine traffic. I know we've talked about sprinklers before. Traffic's really good to keep in mind here in terms of maybe the cars that could go along a particular road in a certain amount of time, or the time it might take the cars to travel. Because having a look here, yes, there's 35 along this road and now 25 along here. And you can imagine mergers, when traffic goes from 2 lanes down into 1, that might cause a bit of congestion. So just try and picture this diagram as we talk through these sections here. So for maximum flow, it involves finding the largest movement possible through a network. So how much traffic could you get through on certain roads from the start, the source, to the end, or the sink node. And this is called its carrying capacity. So how much can it carry at its maximum? Traffic, as I said, is the one to use there. The edge value indicates how much can be carried, so along that edge there. The network will be directed, so it's going to have arrows. And we can break the entire network into individual paths to determine how much goes through each path, and then we'll work out an overall total. So back to that diagram I explained before, the carrying capacity of this arc, so just the capacity then I suppose, is 20. So, and that's numbered along here. Notice it's got arrows to direct us. And so what are the different ways you could go from the source to the sink there? There's 2 different paths here, and then we would have to do this technique to work out what is that carrying capacity all up then. Here's the steps that we need to go through then. So you thinking about one path at a time, writing down the smallest edge value along the route. And by the way, we often go from the top down method. So pick a path that goes along the top first and then find another path later. So the smallest edge value along that route, and that's the maximum capacity. Remember in that previous diagram, I'll just go back, we had a 35 and a 20, right? What is the smallest number out of those? 35 and a 25. 25 is the smallest. So subtract that value from each edge along to find the remaining carrying capacity. So we do 25 subtract 25 and 35 subtract 25. You repeat these steps until each we've exhausted what we can do, which paths, and then we're going to add the recorded values to determine the maximum flow. That might not make sense until we do an example here. Let's go through this. Looking at our diagram, we've got labeled nodes. I think we're told then that the path, we're going from P to Q, and then looking at along each edge, looking at the numbers, have a look where the arrows are and directing us. So let's go from, it says it right at the top there, maximum flow from P to Q. So we need to think of the different ways we can get from P to Q, following the arrows, of course. So let's go the top path first, P, A, B, Q. Look at the 3 numbers along that path, 6, 5, and 3. The maximum capacity is actually 3 because B to Q can't carry any more than that. Yes, A and B and P to A could carry more, but it doesn't matter because by the time you get to here, B to Q, the most, let's say, cars that can go through in a minute is 3. So then it doesn't matter if all of these cars have arrived at B earlier, no more can get through. So we need to look at the actual flow for here. So these are the steps. You write down the path that you've done. You write your 4 capital letters and say what the flow is, 3. And now we do this subtracting and this backtracking idea. You go back from Q. You subtract off that number 3 that you've identified as the flow from each number. So 3 subtract 3 is 0. 5 subtract 3 is 2. And then 6 subtract 3 is 3. Next path. PACQ. PACQ. Looking at the numbers along there. PACQ. The smallest one is 3. So that is its maximum capacity. Write down that path, PACQ. What's its maximum flow? 3. Now you subtract 3 off each of the numbers along that path. We tend to go backwards. So 5 subtract 3 gives us 2. 4 subtract 3 gives us 1. And then 3 subtract 3 gives us 0. Next path. Now, You could argue there's a path going P, A, C, E, Q. However, there's no more paths coming out of P. There's no more capacity along this path, so we can't use that anymore. So this process stops if you've ever got zeros coming out of your source, so coming out of every edge, or there's zeros completely coming into Q. That's when you stop this process. Next path we have along P, C, Q, sort of straight across the middle there. We have a 7 and a 2. The biggest number there is 2. So P, C, Q, write down your path, write down the flow number, 2. Now you go backwards, subtracting 2 off each of those edges. 2 subtract 2 is 0. 7 subtract 2 gives us 5. Next path. We can go from P to C again, and then E to Q. Yes, there are other paths we could go, and it doesn't matter which one you do. We just tend to go top down. If you want to try this and going another way and see if you still get the same answer as me, do that by all means. So P, C, C, E, C, Q. Write down your path. And what's the smallest number there? It's 4. So we subtract 4 off each of the numbers going back. 4 subtract 4 is 0. 4 subtract 4 is 0. 5 subtract 4 is 1. And we're back at the start. Now, look at Q here. It's got zeros coming in. That means there's no other path, there's no other capacity on those edges to get into Q. So it doesn't matter what's happened anywhere else along here, we can't get in. So that's when we stop. And that's what our note says here. All of them leading into the sync node are 0, so there's no more flow, so that's where we stop. And as I mentioned before, we also stop if the edges leading out of the source node, P, they have a capacity of 0 as well. So how do you work out the maximum flow? You need to add up the numbers that you've got there. 3 plus 3 plus 2 plus 4 gives us 12. We don't know the units. We don't know if it's cars per minute or anything like that. So you can just leave it as 12. There's some problems to do now. Thank you for joining me for this series.